So we're getting to see a lot of new syntax elements in this code, and at this point I would like to revisit these syntax elements, especially references and the StringView organization inside of our string. So I'll just make all of the source files visible like this, and we can begin to examine what we have so far. So actually I want to rearrange this a little bit one more time like this. So we have our main source file, then we have our header file with definition of our string with all of the functions, and this is our implementation file. Okay, so when we create a string named hello right here, the constructor that is being invoked is this constructor, basically constructor of the string class, which is taking pointer to a constant character, which is of course this character right here that we're going to remember. But instead of remembering it directly in our second version of the string class, instead of remembering it directly in our member variable of some sort, we're creating StringView. StringView, if you read documentation for StringView right here on Learn CPP, I will provide this link for you to check it out. StringView is going to be created inside of our string. So this is supposedly our string, and we have these characters allocated in memory. And now we've constructed right here, as soon as string is constructed, StringView object is also constructed, and of course it's a sub-object or data member of the string itself. So StringView will be placed directly inside the string, so it will contain string internally. So this is the outer box is the string, okay, and the inner box is the StringView. And this StringView, when it gets created, this is the constructor that we call over here. We're asking StringView to accept pointer to the string, the address of the string. And of course the StringView will remember this pointer and will be remembering where this string is. So then in our main function, when we say hello, okay, and we use cout as the character output and copy of our variable, we already discussed that this function here is invoked. I will now resize this to make it visible and scroll down to it. So at this stage, when compiler sees this syntax, this operator right here, it will search for a function named operator with this suffix operator sign, and it finds it and it checks whether the left hand side matches something that appears here on the left hand side of this operator, and it appears that cout is of this type, output stream. And then it also looks up the type of hello, which is our string, and it finds that we also have this type on the right hand side. So it matches both left hand side and right hand side for this specific function. And then also we use references to output stream and reference to a string object by specifying these ampersand signs. They're called references in C++. What references provide, the references are basically become second name to the original object, which means that this OSTR identifier of our input parameter to this operator it just becomes the second name for cout right here. And likewise, str becomes the second name for the second argument of this operator, which is this string hello. And therefore, when inside this operator we write ostr output sign str.StringView, this, of course, remains the reference to the original cout object, and this stir right here likewise remains a reference to this object. None of them are copied, so the two original objects are being used because we're specifying references, which is done by these ampersand signs that we use with our parameters. And then what we take advantage of is that this stir view right here, of course, it's a sub-object, an object that exists inside the string. So at runtime, when the string is constructed, this is contained within our string. So we use it because StringView in its own self overrides this operator and knows how to communicate to cout properly and make it display the encapsulated string. So this is what we have so far on this line. Okay, so once again, compiler finds appropriate operator, matches left-hand side and right-hand side. We use these left-hand side and right-hand side by references, and therefore this operator gets direct access to the two original objects created inside main. Rather, cout is declared inside IOStream. And one final touch is that we, by design, we keep the string view private inside our class string. We never set public by default. When you start the class and start writing the code, string view is private. And this operator function does not belong to string. So this is why, in order for this function to be able to access this object which is private inside the class, we use this trick to add a friend declaration, which is, by the way, exactly the same as this, right? It's just basically the signature of this operator is exactly as this. We just add semicolon, which is a declaration, and we make it a friend declaration. Friend declaration tells compiler that this function is a friend of this class, and therefore we would like to remove any restrictions of this function to access any of the data members, including private data members of this class. So this is what we have wired so far into all of this setup we use with the string, and we're trying to make our best effort to make the string behave exactly like on one side as an object which can very easily communicate itself to cout, which we manage through this operator, but also support these functions which are commonly found in the interface of a Java-like string. But we'd like to kind of simulate Java string inside our C++ environment.